Hi everyone, my name is Eric Gumanovsky. I'm the Chief Product Officer for Cloud Security at Tenable. And today I'm going to talk to you about this fancy marketing title that we have here. Thanks, Dana, for that. Managing your cloud security universe as one. Now, what do we mean by managing your cloud security universe as one? It means looking holistically at your entire cloud infrastructure and looking at the risks that can come together to really help adversaries compromise your cloud infrastructure and how you could be managing that better in a better way. So let's start with some interesting numbers that we have here, and it's a small spoiler alert. It's part of a big research that we're going to publish in the coming months, and we have just some interesting snippets from that research that we were able to identify from our customers. So one interesting point here that you can see is that 90% of cloud users, right, have administrative or privileged access in their environments. Now, we know that only 1/3 of these users are maybe using some of these permissions. Most of them are not using any of those permissions at all, right? And this is a very interesting point, right? You have users utilizing your public cloud infrastructure. They might have administrative access. They might have otherwise privileged access. By the way, in the cloud, you don't really need administrative access to cause damage or access interesting data. For example, we're all here in the AWS conference, right? AWS Simple Storage Service, S3, has 94 different permissions. I don't need admin access to be able to access the information stored in those buckets in order to read that data or get this data out of the customer environment. And we have monitored, I think, thousands of customers, millions of those users in public cloud infrastructure environments, and we analyzed the permissions that they have and the permissions that they're using, and we were able to understand that the vast majority of users in cloud infrastructure are overprivileged. Now, that's interesting, but in itself, it does not necessarily directly pose threat or risk to your cloud infrastructure environment, because for that to be exploited, someone actually has to go and compromise those users, right? Someone has to take over those users. And by the way, those users can be human users like you and me. Maybe not all of us are humans here, but most of us are, and we can actually access the information. But these could also be machine users. Those could be service accounts that applications are using in order to be able to access databases or information stored by those applications in storage environments. Another interesting insight that we have seen from our research, and here you have a very interesting graph that shows a number of compute resources that were infected by a critical vulnerability. So you have here a point in time when a critical vulnerability was discovered and published, right? And what you can see here is a number of total assets that we were able at Tenable to discover that were affected by that vulnerability. And we were also able to track how many of those assets were remediated and how many stayed affected, right? And you can see that the remediation of even the most critical vulnerabilities today in large enterprises takes a lot of time. And it doesn't really matter if we're talking about machines deployed in traditional data centers or in the cloud. Here specifically, we are actually focusing on compute resources that run in the cloud, right? We're not talking about traditional data centers that might be, in many cases, more difficult to patch. We're here talking actually about machines running in environments like AWS, right? So you can see that it took most of the customers months to remediate those vulnerabilities, and after we started late January, late May, so we're talking February, March, April, May, 4 months out, 60% of the initially vulnerable compute resources were still vulnerable 4 months out, right? It means that patching vulnerabilities still takes a lot of time, right? We all come to think that, vulnerabilities, there is nothing new in this world. It's as old as compute resources. We all know how to detect vulnerabilities. Cloud offers us numerous ways to detect vulnerabilities. And, it's very easy to remediate vulnerabilities in the cloud. But, truth being said, it actually not as easy and not as fast as people come to think of that. That said, if you look at vulnerabilities in a silo, even the most critical vulnerabilities, it's not a direct threat to your organization. Because if we're talking about a compute resource that has a critical vulnerability, someone still needs access to that compute resource. Someone still needs the ability to talk to that compute resource in order to be able to exploit that vulnerability. And even if they exploit the vulnerability, they get access to a singular machine. That singular machine in itself might not hold any sensitive information, right? So it's important to identify those vulnerabilities. It's very important to patch those vulnerabilities, but those vulnerabilities in itself, they don't pose a direct risk. Another story that we can talk about here is that we still see a lot of very basic network misconfigurations in the cloud that expose critical machines. You see here that 40% of Kubernetes clusters in the cloud have internet-facing APIs. So we're talking here about a situation where you have a Kubernetes cluster that's running some of those machines, and the management API of that Kubernetes cluster is basically wide open to the internet. Now, a more interesting figure that we don't have here in this presentation, but it will be published in the upcoming report, that this talks about individual Kubernetes clusters. But when you think of organizations out there, 80% of organizations out there have Kubernetes clusters with publicly exposed APIs. So 4 out of 5 organizations there have a Kubernetes cluster API exposed to the wide internet, right? Now, again, in itself, that does not necessarily pose a direct risk, because for someone to exploit that, they need to be able to not only talk to that API, but for that API also to have a vulnerability that they can exploit, right? In itself, this is not enough. But here is the interesting point. 40% of organizations have what we call toxic combinations. And this is a perfect storm situation where they have a publicly facing compute resource that is accessible from the entire internet on some port. That port there is an application listening on that port, on that compute resource. That application has a critical vulnerability that someone who's talking to that port over the internet can actually exploit. And once they actually go and compromise that machine, now they have access to a privileged service account that would allow the threat actor access to sensitive information within that specific organization cloud infrastructure. So we're not talking about those individual vulnerabilities or privileged permissions or network exposures. We're talking about toxic combinations of all of that together in one single organization. And as you can see here from a research that we have done, monitoring thousands of organizations, millions of cloud accounts out there, tens or hundreds of millions of workloads, where we're able to identify that 40% of organizations are susceptible to those types of attacks. 40% of organizations actually have an internet-facing vulnerable compute resources with access to sensitive data. Now, you might ask me, okay, what do I do about this? And this is where the modern CNAPP or cloud network application protection solutions like Tenable Cloud Security kick in, right? Because we actually help our customers manage their security universe as one. We look across the stack, we look at workloads, we look at their network exposures, we look at the privileges of those service accounts. We do that by natively integrating various cloud security traditional solutions like CSPM, CWP, CIM, and more. And we need a dedicated lecture to talk about all these fancy C words, but we basically look across the stack. We take all these insights together, we bring all these insights together, we take all that rich context, and we help customers see that all rich context in specific findings that they can go and look at and remediate. And this rich context basically helps customers prioritize, because you never have one critical vulnerability in your environment. You have tens, hundreds, sometimes thousands of critical vulnerabilities. You never have a single server exposed to the internet. You might have a dozen, or you might have 100. You never have a single privileged or overprivileged service account in your organization. So how do you go and prioritize? How you actually go and identify those toxic combinations that we talked about? And the only way to do it is by bringing together all that rich context into a single place that allows you to see those interesting findings and helps you prioritize those findings so you can focus on what matters most in your environment. And let's see how it looks like in real life. So welcome to Tenable Cloud Security. Once you log into our platform, you can obviously see all the cloud infrastructures you connect to. You can see all the findings. But what we really want to zoom in here are those toxic combinations that we just talked about, right? You can see here immediately in one place all these various combinations of risks that when they come together, they expose your infrastructure to realistic attack scenarios. So for example, you can see when you have external users that have access to sensitive data in your environment, for example. But the example I want to focus on right now, and the example we just discussed, is this example of workloads that are public, meaning they're exposed to the internet, that run critical vulnerabilities, and also have an access to sensitive data through high privileges in the environment. Now, when you log into Tenable Cloud Security, once you click on these toxic combinations, you immediately can see the breakdown of these toxic combinations by different environments. And when you go to your AWS console and see those services here within the AWS environment, so basically you can see all the EC2 instances, all those workloads that are running in your environment that have both the network exposure, as you can see here on the, as you can see here on the right-hand side, all these machines are exposed to the internet from the entire range of internet IPs. They run with critical vulnerabilities, as you can see here in the environment, and also with privileged permissions. Now let's select maybe an example of these instances. I'm looking into a specific instance here in our environment. This is an EC2 instance, a virtual machine that runs a vulnerable web application in the environment. Once we go to the findings, the public internet here is a little bit slow today. Once we go to the findings, we can see all the findings this specific machine is subject to in one single place. And the context allows us to prioritize those various findings. As you can see, each and every one of the findings is assigned a different level of severity. Some findings are assigned a low level, some are high, and some are critical. Now, what does impact that severity? The fact that this specific machine is public, has a critical vulnerability, and has an overprivileged service account makes all these three findings have a critical level of severity. If I go and remediate one of those findings, for example, if I go and take this machine off the internet, what immediately happened that this finding would disappear because the machine is no more public. But in addition to that, the severity of other findings will immediately be deprioritized. And in this way, Tenable Cloud Security allows you to prioritize the most interesting findings looking beyond the specific silo, looking beyond the silo of the vulnerabilities, looking beyond the silo of the privileged permissions, or looking beyond the silo of the network exposure. Obviously, you can always dive in deeper. So for example, if you want to look at the internet exposure, if I look at the public exposure finding, I will immediately see how my machine is exposed to the internet. I can see my machine here. I can see the ports that are being exposed. I can see the range of IPs on the internet that can access my machine, and I can see the root cause of the exposure through this very helpful, useful graphical representation. For example, I can easily see here, and the networking people here can easily understand that someone was intending to put this machine behind a load balancer, but they misconfigured a security group, they misconfigured the firewall, and in addition to exposing the machine to the load balancer, they exposed it directly to the internet. So with 2 clicks, I can go to the configuration of the security group in my AWS console, or do that directly through the Tenable Cloud Security and remediate that, that specific internet exposure. But if we go back to the findings, we can look at other findings. For example, we can look at the overprivileged role finding. And again, here, it's very easy to see what our machine can actually access in the environment. Our machine is one of those 4 EC2 instances shown here. It has an access to a privileged service account, which in its turn has access to all these sensitive data resources in our environment, including those 4 ES3 buckets. And with Tenable Cloud Security, it's very easy to hit on the remediation bucket, and you can see this very developer-friendly remediation process that you can run. You can push that into your CI/CD pipeline. You can pull it out from Tenable, or you can actually do an automatic remediation through a pull request directly against your cloud code repository if, again, your cloud infrastructure is managed via code, right? So basically, to sum it up, Tenable Cloud Security allows you to easily identify all your toxic combination in one place, allows you to use the rich context that we bring from across the stack, from the network configuration, from the secrets, from the data stores, from the IAM perspective and the privileges, and also from the ability to identify critical vulnerabilities across your entire compute stack. We bring all that rich context together. We automatically identify those toxic combinations. And through that process, we allow you to prioritize the realistic exposures of your public cloud infrastructure. And more than that, we allow you to remediate all that in once. As you might have heard last week, we also announced an acquisition of a data security posture management company. And through that process, we will soon be also bringing the rich data context of your cloud infrastructure into the Tenable Cloud Security platform. So with that, I would like to thank you so much for being today here with us. Again, my name is Eric Gubanovsky. I'm the Chief Product Officer for Cloud Security, and you are all welcome to visit us at our booth.